सर ॲबिलिटी टू वर्कमध्ये पण मार्क्स टाकले सेकंडमध्ये ठीक आहे ना.
Before we go forward, this is the content that is provided in this presentation. Title of our project is Development of Versatile and Fast Algorithm for Optimal Shift Routing System. The main project domain is going to be artificial intelligence and machine learning. As Ashwinja has explained the ML integration in our equation. So why this optimization in shift routing is needed? According to the referred data, about 80% of global trade relies on maritime transport. In this, according to the expenses of overall trade, about 65% of the amount is dependent on fuel. Even if we deduct the 5% of the total expense, about 5 ton per ship can be deducted. Environmental impact. CO2 emission is one of the most efficient way to reduce the global impact on the environment. Fixed speed operation leads to inefficiency. There are many optimization models available for shift routing. In this, they focus on optimization of speed rather than optimizing the load dependent speed. Non-linear fuel consumption. Fuel consumption also depends on the size of our vehicle or ship. For small ships, there is less amount of fuel required that reduces the economic capacity. As Ashwinja said, many routing sister ships are example of routing decision field. Objectives to develop a mixed integer programming model for maritime inventory routing that optimizes both speed and load to minimize fuel cost. Objectives: we are going to develop a MIP model, that is mixed integer programming model, that will focus on load and speed of the load. According to the data acquired, we are going to evaluate the data and prepare a model that will help us in efficiency. Project title: Development of Versatile and Fast Algorithm for Optimal Shift Routing System. The domain is artificial intelligence and machine learning. These are my members: Ashwini Suryavanshi, myself, Arjun, and Krushna Sanap. Introduction. As earlier I mentioned, about 80 to 90% of global trade is via maritime. Shipping industry consumes 250 million metric tons of fuel annually. It accounts for 50 to 70% of total operating cost. Even 1 knot reduction in speed can lead to 10 to 50% of fuel savings. So, as I mentioned earlier, here there is about 250 million metric tons of data fuel used annually. Even if we reduce 5% of that fuel, about 50 million tons can be saved. That will cost millions for our economic system. Why speed optimization is important? Ship fuel consumption is non-linear and depends on weight, weather, and routing. There are three main key points that leads to optimization. First one is speed. Speed can be decided by the weight load that is available on the ship. Weather, and sister ship gives us data of previous load. They provide the weather of that time of condition, and routing can be decided accordingly. Related service. This is the one example of available models that here the gap found will be load dependent. They don't consider the load dependent consumption and it is limited for fuel optimization to do it. These are some other models that were proposed. First one, limitation of first will be high consumption complexity. So the model we are developing will have less complex, that is fluently composed and able and AI will be used to reduce its complexity. Secondly, second is limitation to because there is full and empty words. So our model is going to be dynamic. The shift will be weighted and according to that load, our optimization will be developed. Limitation of load will be close load dependent fuel consumption. So that is the main aspects of our project, our research paper. Load will be limitation for load will be assumes constant load. As I mentioned earlier, we have dynamic load dependency. How our model works. So the basic thing is going to be how we are going to be developing a MIT model, that is mixed integer programming model, and after developing that we are going to use the LAX model, optimization model, that is going to help us in optimizing the MIT model. This model is going to be continuous efficiency, KWS. It saves up to 56% of fuel over traditional models. In traditional model, there is fixed load and fixed speed for the route, and we are going to change that with our dynamic approach methodology. First step of our model is going to be collecting data. That collection of data can be done by available data on the internet, or we can get the data from real-time view. Second is going to be model development. We are going to be developing MIP model based on the data acquired, linearization, and then we come with the approximation. As I earlier mentioned, CPAX is the optimization model that we are going to be using for our MIP optimization result analysis. After developing the model and using CPAX solver, the final results are going to be analyzed, and the difference between traditional model and our model is going to be mentioned. That will result in cost efficiency and less loss of our loads and content. So there are some solutions, but I couldn't place in directly because they were so that equations minimizes the total cost, including fuel consumption and operational cost constraint. There are limiting constraints at certain loads, like results. After our completion of the total model, after approximately this amount of data can be conserved. Load dependent speed optimization reduces cost by 20% compared to the traditional method, like speed only optimization. Second is total cost saving of 56 compared to the speed model. Speed and load analysis, about 25% of the load can be of the fuel can be conserved by optimizing our load dependent fuel consumption. Vessels operate at lower loads structure analysis. Speed optimization impacts routing distance in certain amount of CO2 emissions is optimal for their routing, and they can take down if that CO2 emission is over. That our model helps them reduce this CO2 emission that helps them. Our model is also going to be implemented with the data that will help the optimal shift of in future their shifts will move from petrol to LNG, hydrogen and hydrogen. These petroleum engines can change the efficiency of overall structure. As we know, the market collapses and rises up in very different manner. We can introduce a prediction model in our project that will predict the future prices of fuel, that will forecast the total cost of our model. So, implications of the study. Assumptions of simplified fuel consumption function. Our model approximates fuel consumption using linearization technique. Conclusion. Conclusion of our overall model is we are going to be making a MID model that will help in our overall model that will save up to 26% over heat exchange. Traditional models assume constant speed or they changes the route, but in our model we include all the aspects and give them overall a better model than previously imposed. These are the references we have used.
What is the title of this paper?
Load dependent fuel optimization.
What?
Load dependent fuel optimization in maritime transport.
How you are going to save the fuel?
Ma'am, there are three aspects in saving the fuel. First will be changing the route according to the weather data we have been provided from satellites or previously used data sets. This weather data will help us in changing the route according to the weather conditions of that specific location. That will help in the loss of containers or other load that is present on the ship.
ठीक है.